All right, class. So today we're going to talk about how we could graph linear inequalities in two variables. So it is very similar to how we graphed linear equations. So in this case, we're either going to have the inequality given to us in slope intercept form or in standard form, right? And based on whatever it is, we're going to use certain aspects of the equation to help us graph it. And the other thing that's unique to inequalities is that when we are graphing them, we have to keep in mind whether the boundary line is going to be a dashed line or a solid line, meaning that if all those points on the line are included or not included, right? So if they're not included, it'll be a dash, so it's less than or greater than. But if those values are also included, then we will have a solid line. So we'll cross that bridge when we get there. But let's get started with this one. So the first one is in slope intercept form, right? We kind of see it. We have mx minus 4 in this instead of plus b minus b. But here our slope we could identify as the value in front of the x, which is 3, which is the same thing as 3 over 1. In this case, our slope is positive. So that means that we'll have rise over run. And then we have to also identify the y-intercept, in this case, -4, right? Which is our starting value, right? Our starting point here. And then lastly, we have to decide whether it's going to be a solid line or a dashed line. So again, this one's less than, right? We can see that it's just less than in this case, right? And because of it, that means it's going to be a dashed line in this case, okay? So we'll get started by plotting the y-intercept at -4 in this case. Then we have a slope of 3 over 1, so up 3, so 1, 2, 3, run 1, up 1, 2, 3, run 1, right? You could do that as many times as you want. You only really need 2 points, to make a line, but I sometimes do a little bit more to ensure that I have a straight line when I'm creating that with my ruler, right? So it's important that we are mindful of that. Sorry, and in this case, we actually said it was going to be dash, right? So because it was just less than, so my bad, it shouldn't be a full. So I'm going to just do like a little dash, connecting my points, right? Maybe that's not the best. It's so hard with the iPad to do that. But more like this, like dash. It's not a full solid line. So that means that those values are not going to be included, but we have to determine what values can we include. So in this case, we're going to test a point. You could test any point on the coordinate grid, but I tend, just similar to when we were doing linear solving the inequalities, right? In this, because in one variable, we had to ensure that we tested a point. And in this case, anytime I'm able to, I'm going to try to do 0, 0. My second best point, I think it's like 1, 1, right? It makes it easy. But if I could test 0, 0, then oftentimes that's the easiest value I could test. So in this case, I'll test 0, 0 into the inequality. So I get y was less than 3x minus 4. So we'll substitute that. So 3 times 0 minus 4. That's just 0. So 0 is less than -4. Is 0 less than -4? The answer is no, it's not. So it's false, right? So that means that all the points on where 0, 0 are false. And that means that we have to shade the opposite side. So in this case, we will have to shade the opposite side. And but us shading this side, that means that all the values to the right-hand side of this boundary line, right, the dashed line, that means that all these values that we're here putting in red these are all solutions. So everything inside this region right here are all solutions, except, right, except the actual values on the line, because we did say it was dashed, so that meant that those values were not included. So let's take a look now at the second one. We get a slope of -4 over 1 again. This slope is negative, so actually will be fall over run. And then our y-intercept for this one's at positive 8, right? So it's our starting point. And then lastly, is this going to be dashed or solid? Well, in this case, the symbol is greater than or equal to, right? So that means it'll be a solid line in this case. So we'll see what that difference is with the solid line. So let's get going. We start at positive 8. So up here, we have a slope of -4, right? So we go down 1, 2, 3, 4, 1 to the right. Down 1, 2, 3, 4, 1 to the right. Do one more time. 1, 2, 3, 4, 1 to the right. So it'll be somewhere here. And again, I'm going to make my boundary line in this case. Connecting my points. Again, it was solid, so that's why it's solid like this in this one. Right? Again, this is going to go up and down. And again, I got to test the point. I'm going to test, in this case, the line's not going over 0, 0, so it's still a good testing point. So 0, 0, so I'm going to get y was greater than or equal to -4x plus 8. So we get 0 is greater than or equal to -4 times 0 plus 8. So we get 0 is greater than or equal to, that's just 0. So that means it's 8. Is 0 greater than or equal to 8? Nope, that's false. So again, this is false. So therefore, the opposite side will be the solutions, right? So that means we'll be shading on this side. We're going to shade on the right-hand side of the line in this case. And that means that the side where we're shading it in red, these are all possible solutions in this case of this inequality. So that's how we do it when it comes to having them in slope-intercept form, right? But then there are times, in this case, right, where we might have it in standard form, right? So that's going to be a little different, right? Because in this case, we can identify the slope of the y-intercept just by looking at the inequality. We actually would want to approach it by finding the x and y-intercepts in here. So in this case, we have this first inequality, 6x minus 3y is greater than or equal to 18. So in this case, we first want to find the y-intercept. So we do that by setting x is equal to 0. And then we'll find the x-intercept by setting y equal to 0. Okay? So in this case, we're going to first start by setting x is equal to 0 to find the y-intercept. So we will get 6 times 0. Again, I'm using the equation, the original, not equation, but inequality. So 6 times 0 minus 3y is greater than or equal to 18. This is just 6 times 0 is just 0. So we get -3y is greater than or equal to 18. Divide by -3. Again, we're dividing by -3, so y will actually be less than or equal to 18 divided by -6 is -6. So that means that my y-intercept, right, would be crossing the y-axis at -6. So that's down here. So I found my first point. So my y-intercept. But now I got to find the x-intercept. Where is it intersecting in the x-axis, right? So I figure that out by setting y equal to 0. So I get 6x minus 3 times 0 is greater than or equal to 18. This just becomes 0. So I have 6x is greater than or equal to 18. Divide by 6 to both sides. And we get that x is greater than or equal to 3 in this case. So the value of x, right, where it's intersecting the x-axis is a +3 in this case. So the other thing we have to determine, again, when graphing is whether they're going to be a solid region line or a dashed one, right? So in this case is greater than or equal to. So again, greater than or equal to was a solid line. So that will remain as a solid line. So let's go ahead and graph it then, right? So we have now these points here, so solid. So boom, make sure they go over through the points. All right. And then we test the point again. In this case, we could do 0, 0 again. So let's test it. So we get testing 0, 0. So we get 6 times 0 minus 3 times 0 has to be greater than or equal to 18. Well, 6 times 0 and 3 times 0 are just 0. So everything's going to be zeroed out. Is greater than or equal to 18. So is 0 greater than or equal to 18? Nope, it's false. Right, so this was false. So that means we shade on the right-hand side of the coordinate plane, right? Right-hand side. And again, just like the other example, that means that these are the solutions, everything inside this region that it's in red. And in this case, also including the line, right? All the points on the line, because we're saying that all those points are also included in the solution set. So hopefully that worked and helped you there. I'm gonna do one more in standard form, so you guys have another example. So let's do this one. So again, we're gonna find the y-intercept first, then the x-intercept. So in this case, let's start with the y-intercept. So set x is equal to 0. So 4 times 0 plus 2y is less than 12. 4 times 0 is just 0, so we get 2y is less than 12. Divide by 2 to both sides. Now I could leave y by itself, so y is less than 6. And now we have, so that means y is at 6, right? Is the y-intercept here, so I'm going to plot that. And now I'm going to set y equal to 0 to find the x-intercept, right? So we have 4x plus 2 times 0 is less than 12, so that cancels. So we get 4x is less than 12. Divide by 4 to both sides, so x is less than 3. So in this case, it would be at 3. So is this a solid or a dashed line? That's the next question we want to ask yourself. Is dashed, right? It was just less than. So again, when we have that, we just kind of dash the line. So maybe a little easier because you still have the ruler, right? I can't really use a ruler in the iPad, but it'll be more like a dash line in this case, right? Instead of a solid line like this one over here. So in this case, again, we test a point. In this case, 0, 0 is still open for us to use as a testing point. It's not going through the line. So let's test this. So we get 4 times 0 plus 2 times 0 has to be less than 12. So 0 and 0, 0 plus 0 is 0, is less than 12. In this case is actually true, right? 0 is less than 12. So because that was true, that means that we're going to shade on this side, the same side of their testing point, because that point was true. So we're going to shade to the left in this case. And that means that everything inside here are possible solutions. So all this region here, except the boundary line, right? There was dash. So that means that those values are not solutions and they're not included in the solution set. And that is how we are able to graph linear inequalities in two variables, whether they are in slope intercept or in standard form. Hope that helps.